comes up with diisopropyl ether water, and you say one choice there. If you click this arrow, you may see more choices. Click this arrow. You can see we have 4 choices. Each one of them gives us a different set of parameters. One of them you say is supposed to be better, for example, for LLE. The others are supposed to be better for BLE. Actually, to be honest, this is supposed to be better for BLE. If you use ideal gas, this is RK, and this is better for LLE. So you have a choice of different parameters from here. And look at the parameters that we have. AIJ, AJI. These are the same as the AIJ, AJI of Unisim, with one exception. It's flipped, it's transposed. So in Unisim, what do I have here? Ether, water. So if we go back to this Excel spreadsheet, here's ether, water. First component, the I component here is ether. The J component is water. You would think ether, water would have been, well, okay, it's there. It would have been ether, water, this component. No, it's flipped. The ether, water, you would take ether from the column and water from the row. Would be this. B, same thing. So notice the A's are 0 as in here, but let's go to the B's. So for example, B, ether, water, 770. It's not ether, water, this one, it's this one. So what is 993 here is 770 here. BJI, 1484. That BJI, okay, that would be column, water, okay, I is water, sorry, yeah. So BIJ is this one, BJI will be this one. So the 1484 is what is here 24. Drastically different. So you can see the ether water requirements are drastically different. And this is the default of Aspen. So you can see how different the default of Aspen is from the default of Unisim. Alpha 1, these are practically the same, 0.297, 0.3. There's no difference. So how do let's put in here the parameters that we got from Unisim. So I'm going to change those parameters. So the A stays 0. And remember also, the other thing that I mentioned, Aspen Cij is the alpha 1 ij of Unisim. So Aspen C is Unisim alpha 1. Right. So let's go ahead and change those. So this is water ether, the 424. So control copy, and you can go. So this is, oh, wait a minute, I have water acetic acid. So here we go. Control copy. So that 24 would be water ether in here. So the water ether is the 1484. Control V. That's the value here. The value of the next one. The 993 is, notice it reset the other also. The 993, control copy, is what was before here, 700 something. And 0.2997, sorry, 0.297, no wait, oh, it's 0.223, sorry. Ether water is 0.223. It's not the same. 0.223. Control copy. Control this. So this is for ether water. We also have two other interactions. You can carry it, go here, and add now, for example, acetic acid water. And by the way, you notice this was user parameters now. And no choices. Oh, here, no place. Okay. It has only one option for this. These are the parameters that you can get from Aspen. So depending on the binary pair, you can get as many as 4 options, as few as just one option. Okay? And the last one we would have to do next, we have to do one more, and that would be the acetic acid ether. And this will have some parameters. I have 5 minutes only, and anyway, I want to definitely redo that when you have Aspen, or at least most of the class has Aspen. But once you have specified the parameters, you can go now and get ternary plots. So where you would go here, we see analysis, residue curves, and okay, that's not the one I want. Ternary diagram, sorry, that's what I want. Ternary diagram. Analysis. Here we go. So, for each set of parameters, you can get a ternary diagram like that. So here you can see this is acetic acid here. Okay, so no, sorry, here's, okay, here is ether, mole fraction ether, so ether is here. This is water, this is acetic acid. So you can say ether, water, there's an immiscible region according to those parameters. It's probably way too small. Okay? So what we will see next Friday, we're going to enter here the composition of our feed. And we see that our feed falls in the region where there's only one phase, according to the default units parameter. Okay? Say again? The parameters, of course. The parameters that the default parameters for Unisim are totally bad for liquid-liquid extraction. On your project, you have the ability to use multiple sets of parameters. You have distillation columns. Distillation columns are vapor-liquid equilibrium. For this, you want to use parameters that are good for vapor-liquid equilibrium. You'll probably be doing decanting. One good technique for separating the water ethanol azeotrope, puts an entrainer that is partially miscible with water, and you have a 3-phase region, and you go to on the condenser, you have a decanter, and after you condense, you have 2 liquid phases, and you recycle only one of the 2 liquid phases. So that's one technique to get past the azeotrope of water ethanol. So what we will do then, we separate the distillation column into 2 sections. One section before the condenser is going to be using vapor-liquid equilibrium parameters. The section with the condenser will be using liquid-liquid equilibrium parameters. Yes. There will be a homologue. All right.